Now this question is 2008 Pure Physics question 11OR. So it's a question about a fixed resistor in series with a input transducer. In this case is a thermistor. Now even though this is a pure physics question, it's relevant to combined science because it came out a few times or so, even though you don't learn thermistor per se, but in the question, as long as they give you certain information about thermistor, they can still ask you as a question. Now for part A, you are asked why the voltmeter reading increases as the temperature rises. Now you have to pay attention, they are referring to the voltmeter that's across the fixed resistor of 1600 ohms. And later I'm going to ask you about the potential difference across the thermistor, because that is actually more difficult and it's a common kind of question. So let's start with this. So you will always explain step by step as the temperature increases. I'm going to write in short form, so when you write, please write in full. As the temperature rises, the resistance of the thermistor will decrease, and before you talk about the current for the whole circuit, you have to mention about the total effective resistance, which is the sum of both components. Then the total effective resistance will decrease, therefore the current flowing through the circuit will increase. So next, since they are asking about this voltmeter across the fixed resistor, is very simple. So since V equals to IR, where R is constant, for this case 1006 ohms, so the potential difference will be directly proportional to your current flowing through the fixed resistor. So you already concluded that since your current flowing through the fixed resistor increases, therefore the voltmeter reading will increase. So this is actually very straightforward, purely because they are asking you the voltmeter reading across the fixed resistor. But I want to bring your attention to what if I were to ask you the potential difference. If I put a voltmeter across the thermistor and I ask you about this voltmeter. Now there's a common mistake. If you were to use the potential difference equals to V equals to IR, and this is the resistance of the thermistor, you can't use this just like what we did here. Yes, you can, because it's a fixed resistor, but for the thermistor, you can see that there's a problem here, because the current, we already said that the current will be increasing, but the resistance of the thermistor will decrease. So you can see that, I mean, it contradicts each other. There's no way I can convince the marker that this is the potential difference across the thermistor will increase or decrease. So what do you do if I were to ask you for potential difference across T? You still have to explain all this that you have written here, and you make use of, basically you're making use of the fixed resistor to explain that the potential difference across the fixed resistor is increased. Okay, then you use the concept that both thermistor and the fixed resistor, they are connected in series. So in other words, the potential sum of potential difference of the fixed resistor plus the potential difference across the thermistor, that will be your 6.0 volt, the EMF. Using this relationship and the understanding, since I already conclude that the potential difference across fixed resistor has to increase, the V across the T will have to decrease. All right, so that's how you explain if they were to ask you about the potential difference across thermistor. Now for part B, you're asked to find the resistance of the thermistor when the temperature is 40 degrees Celsius. So from the graph, one thing you need to take note is this V, the V reading is for the fixed resistor, not the thermistor. So when the temperature is 40 degrees Celsius, all right, you just draw the vertical line or dotted line, and then you draw horizontally, and you'll get that the 3.6 volt, that will be the potential difference across the fixed resistor. So don't make a careless mistake there. So if here is 3.6, all right, and since the thermistor and the fixed resistor are connected in series, you know, to find the potential difference across the thermistor, you can just take 6, the EMF, minus away 3.6, and it will be 2.4 volt across the thermistor. So these are basic concepts that you know. There are basically two methods to do this. I'll show you both. All right, so the first thing you need to do is using the usual way. So to find the current flowing through the fixed resistor, because you know that the V across the fixed resistor is 3.6, so I equals to V over R. The potential difference across is 3.6, and the resistance of the fixed resistor is 1006. So from here you know that the current flowing through the fixed resistor is this current, and because they're connected in series, so the current throughout the whole circuit including the thermistor will be the same. This is the current for the thermistor also. Then another thing, like I mentioned already, the potential difference across the thermistor you can actually find taking the EMF, which is 6.0, minus away the potential difference across the fixed resistor, which we already found from the graph. So it will be 2.4 volt. So once you have this information, I can find the resistance of the thermistor using V over I. The potential difference across the thermistor is 2.4, and the current, which is constant. So therefore you will get 1066.67, and if you round to 2 sig fig, there will be 1100 ohms. So that will be the answer. Now another method is, because for pure physics you learn like the formula for the potential divider. As mentioned, the potential difference across the thermistor is 2.4 volt, so you can use the proportion method, or some of you remember it as a formula. So 2.4 volt, and what proportion of the EMF is taken by this thermistor, so that will be the resistance of the thermistor over the total units for the two resistance, which is RT plus 1006 times the EMF, that's the supply. And you can solve, okay, this is just simple math, and if you solve it, that will be the same answer. So we can use this also. Next part here, okay, which is quite common and important, you're supposed to draw a graph to show how the voltage of the thermistor varies with temperature. Now take note, this voltmeter reading and this graph is for this voltmeter that is across the fixed resistor. Now the question wants you to draw another graph on the same figure 11.2, the potential difference of the thermistor as the temperature varies. So from the concept, the fixed resistor and the thermistor are connected in series, so the sum, if you add up the potential difference of V and the V here, it must be equals to 6. That's a very crucial point. So that means to say you use this point here, the starting, and the voltmeter reading that's over here right now is 0.9. So that means to say if here is 0.9 volt, so the thermistor potential difference will be 6 minus 0.9, therefore you have 5.1 volt here. So another point that you need to plot will be 5.1, which is here. Alright, and another point here, for here, this right now is 5.5, and you will know that if here is 5.5, the potential difference across the thermistor will be 0.5, because the total will be 6, so it will be 0.5. That will be another point. All right, but to draw, you know there is a curve, and so basically whatever 2 points here add up must be 6. Likewise from here and here add up must be 6. So, and you need another point in order to plot a smooth curve, and the best way to do is actually to find that when this is 3 volt, this will be 3 volt also. So I'll be using this point, and this is a point where both curve will pass through, they will intersect. All right, so once you have these 3 points, you can actually just connect them together to your best ability. Okay, that will be the graph for the potential difference across thermistor. So that's how you do it. The last part, you're supposed to describe an experiment using the figure 11.1 to produce the graph of the voltmeter reading in 11.2. So if you were to take a look at this again, so this will be the setup that you have, and what other things you are supposed to include in your experiment in order to get this graph. All right, so let's go back to the space here. So you can see the diagram, the setup here. You can modify the existing circuit a little bit. So you have to place this thermistor inside the water bath. So that's the easiest to actually measure the temperature using a thermometer and then monitor the voltmeter reading. Over here you submerge a heater here, and it has to be placed at the bottom to ensure uniform heating of the water with the convection current. And so you just write step by step. So that's how you, at different temperature you read here, you can record the various voltmeter reading. And of course, to make it better, you can actually put a stirrer inside to ensure even temperature of the liquid. So in general, that's how you solve this question. All right, thank you.